Welcome to a Friday. Tonight I thought I would show you some IDEs I was messing around with. So if you're doing CircuitPython and you want an alternate to Visual Studio and in the CircuitPython extension, possibly because I saw a comment they thought I was spending too much time debugging it. No, you don't learn much if you don't break it apart and figure out what's wrong with it. And I know by default, currently the CircuitPython extension is very old. It is broken out of the box and it has to be fixed before you can use it. So we're going to do a different one. If you've ever seen PyCharm, PyCharm is a piece of the IntelliJ suite of programs. So if you ever done Java and stuff like that from IntelliJ, believe it or not, PyCharm comes from them. So we're going to do the community edition. I've already downloaded it and everything. So we're going to just follow a bit of the steps in here and setting it up. I've already done a dry run on it, but I'll still need the instructions up because there's a couple of spots that are not clear to where you go to them to find stuff. So let's begin. Let's go to our console prompt. And I'm going to go into the work directory. And you see the PyCharm community 2024-23 tar.gz. So first of all, there isn't a Debian package of this. If you go to PyCharm site, there is a third-party installer. There is a snap installer. There is a manual installer, which is what we're going to use. And there was one other, but I'm not a fan of the snap store, so I avoid installing any snaps at all. In fact, I'm pretty sure I don't even have the snap engine running at the moment. Right? PSAX grep snap. I might not even have it running. Just Chromes. There's that one snapshot, blah, blah, blah. There is no snap. Okay? So, CD work. Oh, already in work. So, let's unpack our package, tar zxvf. Z is for compression, X is for extract, V is for verbose, F is for file, and we do PyCharm. Now, by default, PyCharm does not, I believe, create a menu entry on its own. So we have to actually ask it to create a menu entry. In a sense, we create a desktop icon and we can drag it onto my quick launch bar and blah, blah, blah. So if we go into PyCharm now, okay, and if we go into the bin directory, whoops, can you spell bin right? There's PyCharm. And we can just go like so. Now, see this crap that's happening in the back end of the screen? Not allowed to service, blah, 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 crap, blah, blah, blah. Don't worry about it. It's because we're running it at the CLI for the moment while we get started. I'm not going to import from my Visual Studio Code. I don't want to contaminate the brand new one. Don't worry, it's still running. It's busy creating a whole bunch of stuff, and then it just went and put it on another window. Let me bring it back over here again. Okay. Now, the first thing we're going to do is we're going to go to this little wrench down here, this options menu. Create desktop entry. And so now we have a desktop entry. Okay. Now I'm just going to exit it for a sec. And we'll go to an empty desktop. And where did it put it? That's a good question. I don't think it's behind here. And I don't think it's in the folder thing. Well, I know on the VM over there, it created it right away. So let me rerun it again and see if I can create that icon again. For some reason, I wonder if I put it in the menus instead of where it belongs. So let's go development. Yep, there it is. I think this changes if you're GNOME Desky or you're XFCE or whatever. All I know is that on my VM over there, when I did this, I ended up with an icon on my desktop right away. And it could be that this particular layout over here is slightly different than that layout over there. But at least it's in the menu. So if we say add to desktop, and the reason I want to do this is I want to put it in my menu over here. So with all my other editors over there. So if I in KDE, if I click it and hold for a few seconds, it becomes a movable icon. And if I go like this, there you go. Now, as you can see, it's sitting in there. Okay. I don't think I need that, but so now I click it from over here. And it's not running in the background and generating all those Java messages. It is a Java application, so now first thing they would have us do is disable the save, but I can tell you already, not that, this order they have in the website is not very well done. Let's see, all settings. Maybe that'll let me into that. There we go. So right off the bat, they would have me go to system settings, and they would have me go, let's bring it up here. They would not have me turn this one on right here. Oops, you're not seeing this, which is my mistake. Doink. There. They would have me turn this off, but it's already off. And they would have me do this when saving files, blah, 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 so they turn it off. Okay, fine. I can do that. Just means that when you're writing code out in CircuitPython, unlike Visual Studio Code, which automatically saves things as soon as you do an edit change, this one's not going to do it at the moment, unless you turn those back on. But Control S, of course, remember, is our global save hotkey. So now they would have us create a project on the computer's file system. So I will say OK to this. We'll go back to projects. Now I need to go to File Explorer for a sec because I want to make sure I have projects directory for PyCharm. Let's go have a look down here. So there's our community edition, but I don't. So let's create a folder. PyCharm projects. Okay. So now we have a PyCharm projects directory to put our projects in. They would have us create a new project. So we'll go create a new project. Now, this drove me nuts a bit because I don't know, selective blindness maybe. When I was doing the location, I was kind of used to things where, right, you would do /blah, for example. See, that's my project right on the path. But no, it's actually this up here, and it's not here. So we want to go and find our path in work. Where is home? work PyCharm projects, like so. So now our path is that, and it's up here. We're going to do one. Since we're going to put CircuitPython in, and we want to make sure we can do that, I have over here, let's say we just do this little KB RP2040. So I'm going to call my project KB RP2040, like so. Okay. Now make sure that this is picking the Python from your system. On the VM, it wasn't doing that. It was actually picking a Python that I didn't have. I don't know why, but it was. So, Now, in the web page, they would have us, if you can see right here, after you create the project, when you create the project, you're right away doing this add content root. That's not here that way. The interface has changed again from what they document on Adafruit's site. So I would just say create the project first, like so. Now this was the bit of, for me, the bit of a tricky part, is to find out what we had to do was go to the project right here, project structure. There's your current root. And what they're getting at here is they're referring to the CircuitPython drive on this thing. So let me grab the USB-C cable here, and we're going to activate the RB2040. Okay, it's right there. You can see it in the camera. Okay, so it's CircuitPython. I think it's this one. So let's mount it. And we are going to find out. This is where they've added the boot.out text file on all the CircuitPython drives, so that you can figure out Adafruit macro pad. That's not the one we want. Okay, so safely remove. Okay, instead, we probably want this one. And if we look at the boot out thing, let's say we'll just open it with Kate for a sec. And where are you opening it to? Come on. Yeah, I have 32 gig of RAM in here. You'd think sometimes some applications would be faster. Well, I don't know where Kate went to. Okay, let's open the Notepad QQ. There it is. So if we look at the boot out text here, we can see Adafruit KB2040. So we've loaded the correct CircuitPython drive. So here we're going to add a content root. And the way you find it is anything mounted in Linux is under your media directory. So if we go higher up to here, the root of the file system, there should be a media directory right there. And then there's Wilm, and then there's a CircuitPy right there. And we say OK. And we apply. And so OK. Now on the KB2040, you can now see there's a CircuitPy drive there. So, and in it, of course, is all our stuff. Okay. So the actual project control code and everything, kind of like the .VSCode directory in Visual Studio, is on your drive. And the CircuitPy is attached to the project by doing this. Now, of course, at this point in time, we actually don't have support for CircuitPython yet. Okay. So next we need to do is this step here. And that is actually stored in PyPy repository. So when you do a like for the Visual Studio Code CircuitPython extension, when you do the build stubs and boards, and it runs that script, and it goes to Git and downloads CircuitPython, then you prepare the tree, right? But the actual stage it was says build stubs. Reality is it's just in the CircuitPython directory. You can, without that script, you can go into there and say, after it's prepped, you can just say make stubs. And it will go through and make the stubs and generate this big file for you that contains all the stubs. So what we have to do is go down here and we need Python packages. Okay. And let's see, Circuit Python. There we go. CircuitPython. And we scroll down here. There's stubs right there. And we will install it. And I will not take the 920 beta 0. I'll stick with 914. So now we have the CircuitPython stubs installed. And you can see PEP 561. And you can see from the web interface for this, this is a different interface. You can see this doesn't match this one at all. It's done differently. And this part here, yeah. So now I know who did the web page. That was Foamy Guy. And I think it's being pointed out to him. He needs to update the screenshots in there to correspond with the newer versions of PyCharm. Now, this is where that file, the boot out text file, is important because it gives us this board ID. We need it. We have to actually tell this now project which board we're actually using. We've got the stubs, but we haven't told it what board. So we want a console, and I believe we do that for terminal. Okay, got it. Okay. So we are going to do a command on the web page right here. So I've got one thing in my clipboard, a regular, and one thing in my middle paste button. So there's that. And then we do a paste like this. So there, like that. So what you're seeing is CircuitPython_set board space the board ID, which we took out of the bootout.txt file. So now the board is purportedly set. Now we need to install some libraries. Now on this board, we do have a LED NeoPixel on here. So if we look in the original here, we don't have any libraries in here. So we're going to add a library. So we go back to Python packages again. And we say Adafruit -CircuitPython NeoPixel right there. And I'll install that one. And I will use the latest one. Okay. So we should have those two installed. Now this part here is kind of dumb. This is where we're doing the serial console. I just want to check something here. See, this is what I kind of don't like in this thing. The library's installed. That's true. But I don't know where to put it. So we know the package is installed. Right? Some examples, blah, blah, blah. But what I'm thinking of is what's happening here. This stuff is not in here. It's actually, I think, considered external libraries, maybe. This is what I don't understand about PyCharm at the moment. Its order of stuff. So how do you put this library into that thing? Now, I can do it because this is connected. I can use the Circup facility to do this. But my thoughts on this is this should be in here. Right? So if I go, I don't know if in the shell I'll have it. Control R, Python. I'm just seeing if I have that one for updating. Well, Control R, Python, Control R. I'm looking for an instruction that I used to use, but I'm not finding it. Version. Oh, wait a minute. We'll see. Control R, pip. There we go. We need to make sure our circup is up to date, and we should also make sure pip3 is up to date. There we go. So we're up to date. Now we can use circup. We do that, and we say install. Okay, so list that's all. See grep for Neo. Did I get it right? No, list all. What was it again? For listing all the modules. So let's see. List out all the modules finally connected. No, show. That's what we want. Not list. Show. Show. Grep. Neo. So there's our Neo pixel right there. So circ up, install NeoPixel. So you can see upstairs now, lib has something in it now. Okay. I don't need my boot out text anymore, and I don't need what's new to charm. Okay, what we want is our code file. Now our code file, of course, seems to have nothing relevant in it. We need a NeoPixel Blink program just for testing. And let me find Mr. Notepad QQ here. No, that's the Arduino version of it. That should do. Blinks the built-in LED. Oh, wait a minute. That blink maybe was the right one. Nope. Code pi, blink C, main C, code 1 pi. Do I have to go digging for this again? I thought I already had it. Yeah, I suppose I can borrow this one. Control A, Control C. So, place this with Control V. That's why, oops. Sometimes widgets within Linux and or Windows are stupidly done. I don't like the arrow with the sidebar. I prefer 2 angle brackets to indicate that I can move it left and right. But there's our code. And if we Control save it. Now our trick here is we need to know what pixel we're on, not D5 on a KB. So is it written on here? We need to know which pin the NeoPixel's on. I wonder if I just say board dot and NeoPixel. Control S. There we go. You can see it. Red, yellow, green. There you go. It's blue, red. So there you go. The pixel thing. And this is all done within PyCharm. Now, my down things on this. No. Oh, I almost forgot one section. The REPL. So there's no button to turn the REPL on. Right? You can run CodePy, you can do all this thing, but it doesn't say, activate the REPL. Because it actually doesn't know what port it's on. So I do by looking at dmessage, and I can see it is USB master ACM1. So if we go TIO, and I think I have that inside. Nope, I don't. So we have to apt install TIO. You can use TIO or screen. Both will work. Now back to PyCharm here. So TIO dev tty ACM1. And there's our REPL down there. We can say Control C in it, and I just broke the code. We can say Control D, and I started the code again. Right? So yeah, there's no button for making a REPL. It's a little misleading on the packages because yes, even though we installed from the PyPy repo an appropriate NeoPixel library, it's not the actual correct one. That one is for if you're playing with Blinka. So Blinka is everything Adafruit runs as far as CircuitPython, but on small board computers and stuff like this. So if you were doing like the Raspberry Pi or even this PC, you would install Blinka, and then you would install things from there, and then things would work. But a PC like this, of course, there's no GPIO pins. You would have to run something like Adafruit's little USB to GPIO gizmo, where it gives you some GPIO pins hanging off a USB-C port. But if you had these Raspberry Pi or Orange Pi or Banana Pi or any of those things, they all have GPIO pins. And you can install Blinka onto there, and then you would have access to the Pi's GPIO pins. But in our case here, it's done on this microcontroller board, which means you have to have the libs in here, and you have to have the ones built for microcontrollers. I mean, space is a premium on an MCU, and the regular Blinka stuff and that, it wouldn't fit anywhere near on here. It's way too big. You need this instead. And you can see in this lib directory, it's even what they kind of call a compressed Pi file, MPYs. So you see the pixel buffer and the NeoPixel libraries put in there. Okay. So that's another problem in the thing. I think the instructions themselves are okay, but they need updating because obviously IntelliJ's changed the damn interface again to do something different. So it needs pointers. And I still think in the instructions on this page where they start out with disable autosave, I would personally start out with, especially on Linux, create the desktop icon first so you can launch it properly, right? Then maybe turn off autosave, right? And I would expand the project thing where it says create project and then you add the root. No, you need to know where. You have to actually go to PyCharm settings, IDE and project settings, like so. And you have to know to go down here to this folder. Otherwise, you're never going to find, in the project structure, you're never going to find this button. He assumes you know where that is in the tree. No, after you've actually installed it and you've created, it's just starting to create a project. This isn't there. It's like, So that was another thing I didn't like in here. I don't know. I'm a little tossed on the interface itself. I think I kind of like Visual Studio Code's interface a little better. I do believe that the fonts in here, like in Visual Studio Code, you can make them larger and smaller. 1 week warning, parameter weight value is not used. Okay, whatever. It's up to you. Like, I mean, you could choose to do it, but it's manual work. You'll have to use the circup tool, for example, to push libraries into the actual thing. I mean, it is, you can achieve the same type of layout in Visual Studio Code. You just have to make better use of the way the workspaces work. So normally what I simply do is I just create everything on the controller. It's simple, but you can go and make a workspace for a project for this, and you can bind a subdirectory into the workspace that's the controller's one, so that all the things like you call the .VSCode directory and everything doesn't get created on the controller, right? You can do that. But I found that what's in the .VSCode is only a JSON file. So, and it's very tiny. If there's anything else you would be interested in me in doing this, I haven't tried version control or anything like that. I'm still trying to understand some of the menus in here, the way they work. Especially like this whole external libraries tree and the scratches and consoles. I'm not sure what actually happens in that. Right? But as you can see, you can do CircuitPython. Now, if you want that dynamic running where you change something up here and it right away it shows up on the controller, you'll have to turn that auto save and change thing back on. But there you go. That's CircuitPython on PyCharm. Dun, 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 dun. Now I was building with a second environment that was way more complicated than this one. And that is, oops, I'm going to have to close this KB drive correctly. Let me just safely remove. Okay. We don't need that anymore. So this fellow. So if you don't recognize what this is ST Microelectronics Nucleo boards, one of them. And believe me, there's a billion of them. So this top half of the board up here is an ST-Link 2.1 interface. And the bottom half of the board is the actual STM. And in this case, it happens to be an F091RC. That's important to know what it is. Okay. Now, on the chip itself, it's also T6U. So knowing the T6 is actually important too. I believe the letter U references the way it's put on the board, like the Surface package here. Okay. Because ST Microelectronics is not, I would say they're not that good at cataloging everything and they have too much stuff. Right? Now, this particular board has ST Micro pins here, but these things are Arduino standard. You can actually put Arduino framework on here and treat this as an Arduino board. Right? It has all that on it. So, now when I was working with it, let me get this. I think this is the right one. Yep. The only sad thing, this is an old board. I can tell because one of the things on it, it uses micro USB, not mini USB, not micro USB or USB-C. So I'm not actually going to plug it in just yet. So in order to have this environment, there's two ways of doing it. You could sign up to ST Micro, which I did. You can download all the parts you need, including ST Micro's what they call STM32 Cube IDE, or lately they added it into Visual Studio Code. But in order to do it in Visual Studio Code, you have to do some pre-prep work. So, not on root. Let's go back over here to here. So, we need to go back to work. STM32. So what we have here is particularly documentation for this particular board. Well, it's family of boards and the tools we need. So first thing we have to do is uninstall this. Okay. So unzip. Have you ever done NVIDIA driver installs? This is kind of like that. It's like a kind of like a .run file. So we need to change mode 755 to our bundle. Now we can actually run it. Now they say sh st like that to run it. We page through the complete disagreement screen. Okay, I need to sudo this. Now, parts of this tool set will be installed in OPT, and parts will be in your local directory. So we have to install these. Then there's some Linux packages that it's dependent on that we should check to make sure they're installed into the system. And we can, while this is syncing on its install, we'll just bring up Studio Code here. And I'll go to profiles here. And we're going to say I want a new profile. And I will call this STM32. Okay. And we'll copy from default. And we will create. And we will flag it as being the one we want to use. And we can close profiles off. Now we go to extensions here. There are some extensions in here we don't want. We don't need. So not the popular column, not the recommended column. We want the installed. Oops, I have to go back to profile. It didn't install anything. Profiles. We've done that. Extensions. Oh, I think I'm going to have to create this again. I missed this step. Okay. New profile. And we will call it STM32. It didn't create the extensions. Copy from default. Okay. Preview. No, that's not what we want. Okay, create a profile, but it's not actually doing. Select the profile software which you want to. Yeah, that's why I want default. Yeah, so create. Okay. Does default not have that? In use. Extensions. That's strange. I don't have any of my extensions. Okay. What is going on? Default extensions. Well, I know for a fact we need a lot of the stuff from that's used by Expressive IDF. because it's all CMake and stuff. Let me try this one more time here. STM32. Is it SMT or STM? It's STM, not SMT. STM32. We're going to copy it from Express's IDF. That's much better. So all these extensions. Yeah, okay, that's better. And create. Okay. There you go. 29 installed extensions. Okay, there we go. Now there are some extensions here we don't need. Mainly, of course, is this. Uninstall. We don't need that. Telecode that. We can keep. We can take that. I don't need this. I don't need this. Okay, it's all taken out. Great icon, that's fine. Workspace Behave Explorer. It's fine. CMake tools. Enable. I don't remember. I think there's another CMake that I need. Yeah, I need this one. Okay. Now we need STM. So here's the official plugin from them. So there's our prerequisites. There's things you have to install. What I'm after is just a list of other Linux packages. Dependencies here, like this. We have that piece in there. So CC++ extension pack, the CMake tools, CMake, that one. Hex editor, we're missing the hex editor. Microsoft, we'll install that. And Cortex debug. And that's Damaris 25.1. We need that one. ARM assembly. Dan C. Underwood. We'll take that one. Linker script. Zon Wang. Yeah, we'll take that one. And looks like GNU linker map files we need. GNU link. Trends. There we go. Install. Okay. So we've got all these dependency packs in place. Oh, they want the debug tracker VS Code. Do we got that? Did it already input it in for us? Yeah, so we already got that. Okay, good. Memory view, we should got that one in. Yep. Peripheral viewer, RTOS viewer. Yeah, so we got all the dependencies in. Okay. Now details. So they do tell us to have this. I think I already have it installed. Now, problem is I believe in here it's not called this. So apt cache search ncurse. Lib ncurses 5. Ncurses base. Yeah, there's version 5 and version 6. I think this is the one you actually need. Apt install. It's already installed. Yeah, okay. So we come back to here. So now they want us to put in these tools. So we're doing the CLT already, and the CLT was already installed. Okay. Next piece we need from it is to install the CubeMX. And we do an ls minus LA. And there's CubeMX right there. Yeah, it's a big folder. There we go. So minus T on mzip is just to test the zip, but it's also a good way of listing what's in the zip. Okay. We're also going to need the MCU finder. Let's unpack that right now. Oh, yeah. I hate that when it does that. Should have made a subdirectory out of it. mkdir st first one stcubex and stmcu finder krm minus rf Jerry readme okay cd and stm cubex unzip dot this guy. Okay, cd dot cd into st dash mcu finder unzip dot like so. Okay. Okay, so if we go to STM32 QBMX. Okay. I completely disagree. I've read and understood everything. Not. So it's going to install it there, but you could put it elsewhere. But this is fine. I'm the only user on this anyway. Now, CubeMX, what it does is it builds project templates from stuff. It has some issues, and I'll get that in a sec when we do one. Okay, cd dot dot. Now we need to do the last one, st. This is kind of the database of all the boards and the chips from them. There we go. So now if we go to the root of our home here, we can see STM and STC. And if we look in opt, you see ST in here. That one there. Now we've added everything into here. Says there's 2 here. It's complaining about restart extensions. There we go. Okay, I'm just going to restart Visual Studio Code because we did a lot to it. Okay. Now we're going to put the STM in. So we're going to install it. So it's now, there's a new icon over here. You can see it. Now I'm just going to restart it again. I find that play it safe. If you do major stuff like this, you best to restart Visual Studio Code. Okay, so what happens here is it doesn't have the paths. Okay, F1 STM. Okay, this is one of the issues I had. There was a spot in here where you set all the paths. Let me just see if this extension tells me. You have to point to all 3 path places. So this extension settings. There we go. So we need the MX path. So if we CD into CD into ST32 CubeMX, go PWD to get our path. So we need that path. Okay, and we need the path to the actual executable. So ls, I believe it's just this. And we go slash, like so, the program. Then we need the STMCU finder executable. Okay, so we need this piece. / and we need that. Then we need the CLT one. That's the one in opt. So cd opt st cd. Okay, so what do they want? They want just to the folder. So PWD. Okay. Settings should be done. Okay. Now we can test this out by launching the CubeMX, for example. Oh, it's starting on another screen here. There we go. So this is where projects are created. And then the STM32 Finder is where you find boards. So we are going to access to a board selector. I hate it. It's constantly going off to the website to get parts of itself. So in our case, nuke Leo-F091RC is our board. That's down here. This is our board right there. Okay. So if we say start project, and we'll say yes to a lot of this stuff because even I don't understand parts of it. It's very, very configurable. Like, I mean, there's lots of little tricky things you can do. We're just waiting on the it's tedious timing. It takes forever to do certain things in here. Now, while it's working on that, let's go find our file explorer here, which we somehow closed. What we want in here is under work, we want a project folder for STM now. So I have STM32, so we're going to create STM32 projects. Say okay. Okay. So this is what I mean by complex. You can easily actually flag pins and stuff like here, what you want them to do and stuff like this, and it sets the code up. And believe me, just to get an LED to blink on this thing was painful. So I don't think I need to do anything here except I think it's in Project Manager. Yeah. So our Project Manager, we're just going to call it Test 01. We're going to browse our location. Okay. We're not doing eWarm. We're actually doing CMake. Code generator. I think everything is just on defaults. You don't touch anything in here. This is just getting started. And then advanced. You have to define pins and stuff like this. I think everything else isn't here. Yeah, GPO. Um, Now over there on the VM, I actually had some pins predefined for me already. Maybe I have to generate the code first, and then I'll get the preset stuff done. Let's do it. Firmware package. Okay. Updater setting. Yeah, that's fine. Okay. Yes. You'll have to give me a sec here because I actually have to get the login credentials for here. Just hold on, your horsies. Okay. And if you don't mind, I am going to give you the web page side for a sec while I do this. There we go. This is actually for these guys. You can't really get away with not creating an account on their side because you need to log in to different areas and they always ask logins. And if you want to download software, they ask for logins and blah, blah, blah. It's just very tedious, and don't lose the damn password because doing a password reset on ST Micro, holy crap, it's horrible. You could actually wait hours for the password reset link email to come to you. Okay, let's close it. And I'll just minimize this. You might as well not close it because you're probably going to need it again. So now we're going to say import. Okay, I did give it that. So what's going on here? Let's do configuration again. Extension settings. Perhaps I'm not deep enough in the directory. So what are they expecting? Let's try this again. Project importing failed. Can't read properties of target definition. CLT was not found. Why is it not found? That's the right folder. I'm sure I got the path right. Am I not allowed to access it? It's possible. That doesn't make sense. Nope, sorry. I didn't mean to cut and paste that one. PWD, CD, PWD. Copy. Okay, let's just close this for a sec and then open it again. That's better. Okay. So we want work and we want STM projects. Test 01. Okay. Yes, that's better. Import. Open in this window, please. Yes, I completely trust the authors. Yes, I'll send target as debug. No, I don't want that. Okay, now we can plug the board in. Okay. Now it gives us a bunch of buttons, but I found that several of these buttons are kind of useless at the moment. Instead, I usually go to here. So what they've done here is they've turned on every possible button, even though you might not be using all of them. What I've been using is this CMake menu here to do certain things. So in our case, I want to build in Flash. Okay, this is what took me 2 days to solve in here. This particular error. Right here. And it turns out when it builds these templates of these projects, right, they're like superscripts that go and generate all the code lines and everything. Well, guess what? They forgot one. And if I go over to my, where is it? Not Kate. And I open documents. I put it in here. No, I put it in there. My computer. No. Root, home, Willem. I made a note about this and the particular changes I have to do. So, work, STM32, open. So, there's a file in here. This is the fix file. It is actually, if we go back to our file tree here and we go find this file right here. So the first problem's here. Supposed to have the word RAM in it. Okay. Then after some of these greater than signs, there's another issue. So let me find that note. So we fixed the two RAMs in here. So it says RAM at flash, and it's just saying at flash. And that is a line for flash. I have to find the at flash. Just a sec. So I have to find eData, blah, 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 blah. Sections, ISR vector, RO data, ARM, pre, init, vint array, SI data, eData. There you go, at flash. So let me just shove this to the side a little bit. So we want here RAM at flash. And then the next one here is at EBSS. After this greater than symbol, RAM. And then we want user heap stack. Again, after the greater than, RAM, like so. And those are the fixes we need in there. You only have to do this once, and I'm surprised that this should be a bug that should have been fixed with these guys a long time ago. So, bring up our console again here. Terminal. There we go. Come on, new terminal. There we go. We are going to build again. So, CMake, run. We'll build in Flash again. Continue. So we can see here that we then successfully built the code. Now, see this, this is all C language. So see these squigglies with the warnings, unused parameter regulator? Okay. We can actually go into, I believe it's, no, I think it's core, source, drivers, include, and the hell we're interested in is how power. Like so. And what we want in here is a pragma statement. Let me see if I can find it. GCC exclude suppress warning. I think I found it on the Stack Overflow. Yeah, Pragma. Here we go. So what you do is you can hear like so, and then what we're after is output is, where's that? It's a warning. I don't remember what it's called again. Dum, 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 dum. There it is. Unused. This one right here. So we put in here dash unused, close the quotes. Control S. And we should suppress all the warnings on that. So if we go back to our CMake again, we'll just run it again. Build in Flash, continue. See, no warnings anymore. It's not a warning that will stop code. It just means that there's a variable defined that's not getting used. Period. Right? So that's all we're actually doing. And you see it programs a thing, da 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 da. Right? Now, if we want to blink the LED on here, there is what they call ULED2, and it's over here somewhere, right about here. So if we want to blink it, we need the code for that. And STM32 blink LED. So there's a page here. What we're after is the code section here. This. We'll copy that. And we will go back to here into our project. And we don't need the driver section anymore. What we need is, I believe, in main. And what we're after is the while loop at the bottom. Right here. While one. A lot like the Arduino, you have this loop that you put all your code in. So we're going to say here, Control V, Home, Tab, Control S. Now you might be wondering, how do I know it's on GP5? That took a half hour of research to find the spec sheet. That was one of the PDFs. And then looking through the spec sheet, finding this particular board and the mapping for, and it turns out it is number 5. So we'll run it again. Clean and build. Just to make sure we're nice and clean. And we'll do build in Flash again. Continue without. That's fine. Well, it worked on the VMware machine. Must have missed something. Now, this is where, remember in that tool, they talk about pin configurations and stuff like this? Pin out configuration. This was filled in already for me with some pin out stuff, right? And I know it's on PA5. But I don't know what to pick. I have to actually go to the VMware machine and actually look at this because it had these created for me already. Right? So there were about some pins here, like there's about 5 things defined already for me. In this case, they don't have anything. And I'm not sure why they don't have anything. Right? But then again, I don't understand 100% how to even set this up 100% correctly. This is about as far as I've gotten on this. So and what we can do in here too is see, I don't know. System core, GPIO. Oh, this just changed. Now we have GPIO pins. Okay, so we do have that now. Okay. Project manager. We'll call this test 02. And we'll make it CMake. And we'll generate its code. Close. Now over here, file, close folder. And we'll go here and we'll say import CMake project. Work. Test 02. Okay. Yeah. Open in this window. Debug. Now, I have to fix this one, of course. So, RAM, and then it was not ISR vector, it was not ORO data, not ARM, not in array, not fit array. That I believe right there, RAM. And then it was not BSS, it was EBSS, and it was RAM. And user heap stack, it was RAM. I think those are all of them. So we got that one. We got the eData one. Yeah, eData. EBSS. User heap stack. Yep, got them all. Control S. Let's try build again on this guy. Build. Continue. Terminal. Give me a terminal again. There we go. Output. Exit code 0. Okay. So, yeah, we know it's CMake. Yeah, we know it's debug. It's test 02. Okay, we don't need this file. What we do need is to run this thing again. I want to try to push to the device. Still not blinking. Oh, we haven't put the blink code in. Duh. Maybe give me a copy of that. Let us go to the source code. Duh. How will we put the blink code in? Main. Da 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 da. Oops. Da 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 da. While loop. Where are you? There you go. User code goes here. Control V, tab, Control S. Okay, go back to CMake again. I wish some of these buttons in here, like the build and flash, was a button on the bar, but it's not. And I haven't figured out how to do that yet. There we go. One green blinking light. All that effort to make this frickin' LED on this board blink its LED. And all this code just to run this frickin' board. But now I have the STM environment installed into Visual Studio Code. Now they say that you can switch this board over to a Arduino. And I also have here, let me just see if I can find them all. There they are. So these are all ST micros. All these boards in here. But you can see, I'm pretty sure, I think some of these boards, I'll have to have the ST-Link programmer on it. So these blue ones, yeah, and I have another bigger ST micro test board. This one. And I know for a fact that I have to put a programmer on it to program it. And this one happens to be STM F407 VET6. So I remember I have a plug and everything for here because this is like the programming port. And I do have a programmer for this. The black ones are, oh, what are they called again? They're black something, like black pearls or something like that. I can't remember the exact name of them. And then the blue ones are a different one. These ones are F103C6T. This one here is a lot like this Nucleo. And all the jumpers do on here is change the way it boots. So, and then this is my oddball one. This is also a ST. It's kind of similar to these ones, but more I/O on it, I think. Or they changed the way they do the I/O. But you get the idea. Up to this point, I think I was programming this one Arduino style. I'll have to remember on that one. So we are up to an hour and a half. Wow. Okay, so I've done PyCharm and I've done STM32. So I think I'll call it a evening because it's getting kind of late. And we will see you later.